Hi friends, Brian here for Curiodyssey, and I wanted to explore something you've probably tried before. Baking soda and vinegar. Now if you haven't done this before, you should go try it right now. But if you have tried it before, there's probably a way you can investigate it that you haven't tried already. I'm going to show you my favorites. You can try it in a large flat container. Or you can try it in a tall, skinny container. You can even try it in a bag. To do this, you need a zip top bag, and a bin to put it in wouldn't hurt either. And of course you need the baking soda and vinegar. So what you do is you put the vinegar in first, and then you hold the bag this funny way so that the vinegar pools at the bottom. And you can still add the baking soda to the top. So you add your baking soda, and then you try to seal up that bag without letting any of the baking soda mix with the vinegar beneath. And then you squeeze out as much air of it as you can. Make sure it's totally sealed, and then put it down the bin. Have you ever poured a gas? You can pour carbon dioxide gas out of a container, just like this. Wait, what? When you mix baking soda and vinegar, you get three products from that reaction. You get water, something called sodium acetate, and carbon dioxide gas. Carbon dioxide is invisible, and it's more dense than air, so it sinks. It fills up this bin. Gases are fluids just like water is a fluid, so you can pour gases just like you pour water. Even though you can't see the carbon dioxide flowing out of the bin, you can see the result when it hits the candle. I wonder if I could use bubbles to help show the invisible gas. I'm going to try that. So I'm going to take a container, some water, just a little bit, and some Dawn soap, and then I'm going to mix it up. Once I get that nice and mixed, I'm going to add some baking soda and vinegar to my tube, and then I'm going to try and put a bubble film on top of it and see if it'll grow. Once the bubble film is covering the container, the carbon dioxide being made by the reaction can't escape, so it pushes against that film and makes it expand. You can just barely see it on top of that tube. So far, I've just been mixing a little bit of each, and I've got my remains here. But I wonder, how much vinegar and baking soda should I mix so that I don't have any extra vinegar, or in my case, any extra baking soda stuck at the bottom? I wonder what's the right ratio so that I don't have any extra of either. I'm going to find out. So I've got a few glasses here, and I'm going to put a scoop of baking soda in the first, 2 scoops in the second, and 3 scoops in the third. Each scoop is actually half a teaspoon. So I'm going to take my graduated cylinder, and I'm going to fill it right up to the top to 250 milliliters, and I'm just going to pour some vinegar in each cup and let it react. And I'll keep shaking it and shaking it and shaking it and shaking it until it doesn't react anymore. And when I can add some vinegar and it doesn't react, then I'm going to stop, write down the new level of the graduated cylinder, figure out the difference, and move on to the next glass. And then when I'm done, I should have a pretty good metric for how much vinegar it takes to dissolve a scoop of baking soda. It's like the first one stopped reacting after 36 milliliters of vinegar. I added a little bit just after that to make sure it was done reacting. And I'm noticing that the more baking soda I start with, the more time it takes to finish reacting. So I pour some vinegar in, and it bubbles up. And then I shake it, and it bubbles up. And then I shake it, and then it bubbles up. And then I shake it, and then it bubbles up. The third one took forever. But that's why we can speed up video. Alright, it looks like it's slowing down now. Even when I shake it, it doesn't stay bubbly for very long. So I'm getting close. I think that's it. Cool. So it looks like I only had 1 scoop in the first cup, so the math is easy there. 36 milliliters per scoop of baking soda. In the second glass I had 2 scoops, and it took 66 milliliters. So 66 milliliters divided by 2 scoops is gonna equal 33 scoops. No, 33 milliliters per scoop. And then in the third one, what is 250? That's 106 milliliters divided by 3 scoops. Let me think about that for a second. 33, 35. It's going to be 35.3 milliliters per scoop. Now in theory, the bigger of a sample, the more scoops I start with, the more accurate my result will be. And you can see that 35 is between my 1 scoop and my 2 scoop. 35 is between 36 and 33. I hope you enjoyed exploring with baking soda and vinegar. Please do try some experiments of your own, and if you're wondering what to do with all of this leftover stuff, you can just put it down the drain. It won't hurt anything. But it is also a chemical called sodium acetate and lots of water. So if you were to evaporate off most of this water, you'd get sodium acetate, and sodium acetate does this. So here's what you need to make yourself some. You need, of course, some vinegar and some baking soda. You need a scale and a bowl for putting on the scale, a stirring tool, and a pint jar. And an oversized pot. Big pot, very helpful. Before we start, I want to say that this is going to be on your stove for several hours. Plan ahead. And of course, using this stove, make safe choices. We're going to start by measuring our baking soda. We're going to take our scale, stick our bowl on there, and wait for that to say 0. Now I want this to be in grams, because I know we're going to be using 250 grams of baking soda. We're not going to need to measure our vinegar because we're going to use the whole gallon of it. Now that we've got our baking soda measured, we can add it and the vinegar to our pot. So there's our 250 grams of baking soda. And remember I said we're going to use the entire gallon of vinegar. And here's where that oversized pot comes in real useful. You can do this in a smaller pot, but you've got to be a lot more careful when you're adding your vinegar and your baking soda together that it doesn't boil over and make a big mess. So once these two are finished reacting, we're going to turn the heat on, and we want to simmer this gently until it'll fit into a pint jar. This is also what the wooden spoon is for helping this reaction along, and it doesn't hurt to periodically stir this as you're simmering, just to help get some of the extra carbon dioxide out of solution. Okay, that looks pretty good, so I'm going to turn my heat on. And like I said, we want to bring this to a gentle simmer. Now you do want to turn the fan on over your stove, otherwise your whole house is going to smell like vinegar and your family might chase you out of it. Alright, it's been a day. This has cooled down. And what you'll probably find is that you've got this mass of crystals in the bottom and some extra liquid on top. That's okay. That just means we didn't boil it down enough. But we boiled it down enough to get some results. So what you're going to do, take another jar and pour off your extra liquid. So what we're going to do now, this jar, I'm going to go put in a water bath on the stove, and I'll show you that. This jar, you could, if you want, put it in the fridge and then in the freezer. And what will happen, more crystals will precipitate out of it. And you could add those crystals to this jar. Or you can just leave it separate. Okay, so what I've got here is just a pot of water. And I've got some canning jar lid rings in the bottom just to keep this glass off the bottom of the pan. And my intention was to put this in a water bath, turn the heat on so that I can heat up my jar. And what will happen, these crystals will melt into their own water. And we'll see more of that later. But then I got thinking, wouldn't it be great if we could make this go really fast? And I thought, well, why not try using the microwave? So I'm going to try that right now. Alright, that just came out of the microwave for 30 seconds. And you can see in the bottom there is more liquid. And it's warm, so I'm going to try more. After 1 minute more, I've got very liquidy, it's very hot. I'm going to pause before I microwave it again. There's still a good bit of crystal in there, but it's very hot, and I think that heat will dissolve this a little bit. So I'm going to let this sit for a moment before I try again. It has been about 2 more minutes. I went 1 minute and then 30 seconds and then 30 seconds. And in between I stirred this to help dissolve those crystals, to help the heat dissolve those crystals. It's very hot. I'm not going to pick it up anymore because it's painful to hold that way. The only other thing I would say is I got some white crust around the edge after each microwaving, and you can even see a little bit of it here on the rim. And that's what happens when all the water evaporates from some of this substance, the sodium acetate. So what I'm going to do now, I'm going to carry this back to the table and leave it on a trivet so that it can cool down undisturbed, and put the lid back on it. All right, here we are after yet another day. This jar has cooled completely, and what I'm going to do, I'm going to take this lid off, and some crust might fall in and start the reaction on its own. Or you take a seed crystal, like this one, and drop it in.
And there you go. That is sodium acetate. It has turned completely solid. It is entirely crystallized. So I hope you enjoyed this experiment. And if you want more science in your life, be sure to check out Curiodyssey.